A recent and unexpected revelation from the James Webb Space Telescope has significantly drawn the attention of the global scientific community. In a development that few could have anticipated, researchers detected a series of light emissions in deep space, approximately 7 billion kilometers from Earth. These lights appear to resemble artificial urban illumination, the kind typically associated with developed cities on Earth. This finding has reignited long-standing speculation regarding the existence of intelligent, extraterrestrial life and the potential presence of civilizations beyond our solar system. Primary subject of this discovery is Proxima Centauri b, the closest known exoplanet to Earth, orbiting the red dwarf star Proxima Centauri. What makes this finding especially compelling is the detection of bright, highly localized light patterns emerging from the surface of the planet's night side. The nature and consistency of these signals differ from naturally occurring planetary light emissions such as auroras, volcanic activity, or reflected starlight. This has led some scientists to consider the astonishing possibility that these lights could originate from artificial sources, perhaps akin to city infrastructure or technologically advanced settlements. For decades, humankind has been driven by the quest to find signs of life beyond Earth. Every indication, however small, that life might exist elsewhere in the cosmos has been met with intense curiosity and scientific enthusiasm. The current discovery, if verified through further observation and analysis, may represent one of the most promising leads yet in our long-standing search for extraterrestrial life. The James Webb Space Telescope, through its advanced infrared capabilities, has enabled scientists to observe phenomena previously beyond the reach of our instruments. The apparent presence of concentrated light on Proxima Centauri b has left the astronomical community both intrigued and puzzled. Some scientists have speculated that these lights could be the result of alien technology, such as urban development powered by a form of artificial energy. If this interpretation holds true, it would suggest that intelligent life exists on the planet, beings capable of creating infrastructure and harnessing energy in ways that might parallel or even surpass human capabilities. The implications of such a discovery would be profound. Confirmation of intelligent life elsewhere in the universe would fundamentally change our understanding of biology, evolution, and our place in the cosmos. It would suggest that civilizations may develop independently in different parts of the galaxy and that Earth is not a unique cradle for life. This perspective, once purely speculative, is now being examined through data-driven inquiry. NASA engineers, examining the persistent illumination on Proxima Centauri b, have begun to wonder how long these lights might have been active. Could they have been present for centuries, quietly shining across space, undetected until now due to technological limitations? Or are they a recent development, signifying ongoing activity on the planet? These questions are central to the current research efforts surrounding the observation. David Kipping, an astronomer affiliated with Columbia University, has provided valuable insights into the unusual properties of Proxima Centauri b. Unlike most rocky planets, which absorb stellar light and re-emit it as thermal radiation, Proxima b exhibits a distinctive infrared signature. This discrepancy between the planet's surface heating and the expected radiation output suggests a complex interaction between the planet's atmosphere, surface, and possibly even technological activity. The James Webb Space Telescope's precision in capturing infrared signals has played a pivotal role in detecting this anomaly. Since the telescope is specially designed to sense infrared wavelengths, it has proven to be a highly effective instrument for identifying thermal variations on exoplanets. These subtle thermal differences provide essential clues about atmospheric composition and energy flow on planetary surfaces. Using this advanced capability, scientists aim to decipher the planet's atmospheric makeup and evaluate whether it might support life. The telescope's sensitivity allows it to detect even the faintest light emissions, making it possible to explore whether these lights are indeed artificial in nature. It operates within an extremely narrow frequency range, much narrower than that of natural starlight, allowing for the isolation of possible signs of technology-based illumination. Further adding to the planet's intrigue is the stark contrast between its day and night hemispheres. Researchers speculate that the daylight side might be equipped with energy harvesting structures, such as large-scale solar panel installations, while the night side, which experiences colder conditions, might host the observed illumination. The significant temperature disparity between the two hemispheres, likely influenced by atmospheric conditions and possible human-like activity, makes Proxima b an ideal target for ongoing studies. The orbital alignment of the James Webb Space Telescope with Proxima b's own orbit provides a unique observational advantage. The telescope can track the planet's full rotational cycle every 11.2 Earth days, offering comprehensive coverage of its surface features and environmental dynamics. This alignment allows astronomers to monitor changes in the planet's atmosphere and surface characteristics over time. One of the most critical aspects of the ongoing investigation involves examining the planet's atmospheric chemistry. Scientists are particularly interested in detecting gases such as oxygen, water vapor, and methane, which are considered potential indicators of habitability. The presence of these elements in an atmosphere suggests that life-supporting conditions could exist or may have existed on the planet. However, the process of detecting such atmospheric components is highly complex. It involves analyzing the light that passes through the planet's atmosphere when it transits in front of its host star. Even though the James Webb Space Telescope is well equipped to detect molecules like water vapor, carbon dioxide, and methane, it has a more limited capacity to sense oxygen, which remains one of the strongest biosignatures. Despite this limitation, the telescope can also identify other significant markers such as ozone, which might serve as indirect evidence of biological processes. It's essential to recognize that the telescope has observational constraints. It cannot observe all potentially habitable worlds and is primarily limited to studying a select group of exoplanets located relatively close to Earth. Because of these limitations, astronomers are complementing its efforts with terrestrial observatories, such as the Extremely Large Telescope, ELT, which is currently under development and expected to become operational by 2028. This next-generation ground-based telescope will enable much more detailed exploration of distant planetary atmospheres. Looking toward the future, scientists are also working on designing and deploying new space telescopes capable of overcoming current challenges. These future instruments will be tailored to minimize the glare from host stars, making it easier to detect faint reflections of light from exoplanet surfaces. However, researchers will still face the significant challenge of distinguishing between atmospheric gases created by living organisms and those produced through non-biological geological processes. Despite these hurdles, the pace of scientific advancement continues. The James Webb Space Telescope stands as a major leap in our ability to study distant planets, offering new insights into their composition, behavior, and potential for life. Over the decades, countless missions and studies have sought signs of life in the universe, yet definitive evidence remains elusive. Nevertheless, this new discovery represents a meaningful stride in that journey. To date, confirmed detection of a habitable planet has been made, and the age-old question persists: are we alone in the universe? While the answer remains unknown, the tools at our disposal are more powerful than ever. With each new observation, humanity comes closer to unlocking the secrets of the cosmos and discovering whether life in any form exists beyond Earth.